Hi, this is Haotian and I'm Mingsong. In this video, we'll be briefly introducing our project, which is called Sagnac Interferometry in a Non-inertial frame. So this project involves rotation and interferometry. So let's talk about the first term, which is rotation. Things that rotate come in all forms, such as a bullet, a soccer ball, or the Earth itself. The period of rotation of our Earth will be what we approximate as a day. So people in the past have used celestial objects in the sky to calculate the sidereal day of Earth. That is to say that they take reference to an external object. In this case, it will be the fixed stars that are very far away from us. This is called calculating the relative rotation. But what happens if the stars were to suddenly disappear? So we could instead measure the absolute rotation of Earth. This can be done through using a ring, or also known as a Sagnac interferometer. The basic idea is, light from a coherent light source is sent through a beam splitter, where we obtain two beams which travel in the same optical loop but in anti-parallel directions. After finishing the loop, the two beams are then combined to give us an interference pattern.
How this pattern would look like very much depends on the phase difference between the two counter-propagating beams, which was found to be related to the angular frequency of the setup and the area enclosed by the optical loop by physicist George Sagnac. The other two terms in the equation are speed and wavelength of light respectively. In our actual project, we used a 5-meter single-mode optical fiber to create an optical loop, and we mounted the whole interferometer on a DC motor that could rotate the setup with varying angular speeds. So we made the assumption that the light in the single-mode fiber has only fundamental mode in our calculation, so they could be modeled by sinusoidal functions like these. So due to the principle of superposition, the amplitude of the recombined beam can be modeled by phi1 plus phi2, and the intensity can be calculated by taking the square of the amplitude. So after all this modeling, we found that the intensity of the recombined beam has relationship with the phase difference, which is dependent upon the angular velocity of the setup. So we used this heuristic model to give us some statistical confidence in the Sagnac equation before we move on to the next step.
So we use a commercial camera to video the recombined beam for the duration of rotation with varying speed. We then use the sum of all the pixel values for each frame of the video, and this value was our proxy for the relative intensity of the beam. A plot of relative intensity against rotation speed of the setup was obtained and fitted with the equation that was derived. Our statistics indicate a fair goodness of fit. However, our data is also limited because of its lack of range, where the phase difference was not able to cover at least 2 pi. Hence, we were not able to observe a full period of the sinusoidal wave that is the changing relative intensity. Ways to improve this will be to increase our enclosed area by the optical loop using longer fibers, or using a more powerful motor to increase the maximum rotation speed. So linking back to the original question, if we were to rotate a Sagnac interferometer 90 degrees such that the Earth's rotation axis is perpendicular to the enclosed area of the optical loop, and given that the Sagnac interferometer is sensitive enough, it is possible to calculate the absolute rotation of the Earth without needing external reference objects like the stars. Thank you and have a nice day.